Hello everyone, and welcome to our third 9 weeks review of Chapter 7. Remember that Chapter 7 is our polygons chapter, and we had all of those polygon angle sum formulas that we needed to know. So the first set of directions says, solve for the indicated values. So to find the sum of the interior angles, the interior angle sum formula is going to be this one. This is for regular or irregular polygons. Doesn't matter if they're regular or irregular. And so we're just going to plug in n, which is the number of sides. So that's going to be 25 minus 2 times 180. Remember that the 25 minus 2 just represents the number of triangles that are going to be inside of that shape. So while I might not know what a 25-sided figure's angle sum is, I know that there are 23 triangles inside of that shape, so I can use what I know. 23 times 180 degrees in each of those triangles is going to give me a sum of 4,140 degrees. So final answer on number 1 is 4140 for the interior angle sum. So that gives me that total amount, that full amount of what all the angles, all 25 angles would add up to on the inside. So what would be the measure of one interior? So I'm going to underline that word. One interior if it is a regular pentagon. We did have to add the word regular to these instructions. So if it's a regular pentagon, we would do 5 minus 2 times 180 to find the sum. 5 minus 2 times 180 should give me 540. But what am I going to do with 540? I'm going to divide that by the number of sides, because in a regular pentagon, all 5 angles that live inside of that pentagon are going to be the same degree. So I can divide 540 divided by 5, and that is going to give me 108 degrees for all 5 of those interior angles. So what is the measure of just one of them? It would be 108 degrees. Okay. What is the measure of one exterior, so let me underline those words, one exterior angle in a regular dodecagon? Well, remember that dodecagon, so this one was n equals 5. Dodecagon is where n equals 12. Always think do is 2, deca is 10, so 2 plus 10 is 12. So the measure of one exterior is going to be 360 degrees divided by, in a dodecagon, I'm going to have 12 exterior angles. I'm going to divide that by 12. So if it just said, what is the exterior angle sum, you would just straight up say 360 degrees. But if it wants just the measure of 1, that's where we're going to divide it evenly between those 12 angles. And so that's going to give me an exterior angle sum of 360, and the measure of one exterior is going to be 30 degrees. Since it asked for just one exterior, I'm going to say 30 degrees. All right, number 4. Now, this is an irregular polygon. The first thing I want us to do is count the number of sides. It's irregular because not all of the angles are the same, not all the sides are the same. So this is a 6-sided figure. So the first thing I'm going to do is calculate what is the interior angle sum of the shape. So there would be 4 triangles that live inside of this hexagon. So 4 times 180 gives me 720 degrees total. 720 total. So I'm just going to add all of those up to 720. So I can put a 90 here if I need to, so I don't forget to add that. And so I'm going to add them all up. I'm going to say x plus, and I kind of like to underline them as I go, 120 just so I know I've used them, plus 97, plus 130, plus 150, and then don't forget that 90 that I wrote in. Plus 90 should have an interior angle sum of 720 degrees. And then we're just going to do some quick calculations in our calculator to add all of that together for our like terms. 120 plus 97 plus 130 plus 150 plus 90. I got 587, I believe. So x plus 587 is what I've spent on the rest of those angles equals 720. So what is left for x? That's going to be 720 minus 587, and that is going to give me a 133 degrees for that angle. That does look like an obtuse angle in this irregular shape. All of the angles are different, so I cannot use the regular measure of 1 because every single one of these angles is different. So there's 133 degrees left in this 7-sided figure. In the 6-sided figure, 133 degrees left. Okay, so what changes when I go from number 4 to number 5? Let's count the number of sides. So 1, 2, 3, 4, 5, 6, 7. I will be honest with y'all, it's kind of hard for me to see right then if that was a side or not. So another way you can double check this is count the angles. There are 1, 2, 3, 4, 5, 6, 7 angles as well. So we know that this is a 7-sided figure. So this is a heptagon. So how many triangles would live in there? 7 minus 2. So that'd be 5 times 180. 5 times 180, I believe, gives me 900. And it does. All of these blue angles should have a sum of 900 degrees if I add them all up. So what I'm going to do is I'm going to write that out. X plus, let's underline it, 160 plus 2x plus 125 plus 110 plus 112 plus 147 should have a sum of 900 degrees. And then I'm going to combine my like terms. That's 1x plus 2x makes 3x. And then I'm just going to quickly type in 160 plus 125 plus 110 plus 112 plus 147. Grand total of 5. Well, hold on, let me make sure I didn't miss anything. 3x plus 512, so 160 plus 125 plus 110 plus 112 plus 147, 654. So 3x plus 654 equals 900. I knew I had done something wrong because I had a number that was way too small. And so then I'm going to subtract 654 from both sides to figure out what I have left in the budget for the 3x. 3x equals 246. So I'm going to take 246 and I'm going to divide that by 3, and I get 82 for my value of x. So x is 82 degrees. If I wanted to find out what this angle is right here, I would just do 2 times 82, but they did not ask me for that. Okay, so the only thing that changed going from number 4 to number 5 is I went from a 6-sided figure to a 7-sided figure, so my grand total grew. All right, what changes on number 6? Number 6 is a 1, 2, 3, 4, 5-sided figure, but that really doesn't matter. Those numbers don't matter because what kind of angles are on this problem? On this problem, I am dealing with exterior angles, so I'm going to make a note of that. The first thing I notice is that all of these angles are on the outside. So what is always, always, always the grand total of the outside angles in any polygon? 360 degrees. So I'm going to take all 5 of these, 7x plus 83 plus 33 plus 6x plus 49, and I'm going to set that equal to a grand total of 360 degrees since these are exterior angles. Okay, so I'm just going to combine some like terms. I should get 13x plus, let's use our calculator, 83 and 33 and 49 gives me 165. And that should be equal to 360. So then I'm going to subtract 165 from both sides. 360 minus 165 is going to give me 195. Okay, and then when I do 195 divided by 13, I'm going to get 15. So x is equal to 15. All right, so that's the first 6 problems, and I will start our next video here.